In this video, we're going to be talking about moving pawns in Unreal Engine. So by the end of this video, you should end up with something like this. You have a pawn moving, you can turn left or right, you can orient the camera, you can zoom close in and out, or you can change the camera angle. And depending on where you orient the camera, you can change the movement of the pawn. Hopefully this can be the first video of a series of videos where we take a look at something that was made in blueprints. So we start off with a blueprint class and we talk about the movements, and later on we translate that into C++. And so this is a C++ class, and we can tell it's a C++ class because there's no blueprints in here. Actually, let me demo this before I do that. Let me get our second ball, and we notice it does the exact same thing. You can move the camera angle, and this was made 100% in C++. The only thing I did in the editor was assign the material, but everything was made in C++. You see in this example that it behaves exactly like our other ball. So we're gonna get pawns moving, but even more than that, we're gonna do it in two ways. We're gonna do it first in blueprints, and then we're gonna do it in C++. Okay. So let's get to it. So we're gonna create a blank project. Okay. So we're gonna create a blank project, and so let's see. I'll do blank project. Let's name this ball movement. Let's create that. Okay, so we have a blank project. So like I said, we're gonna do this first in blueprints, and then we're gonna do it in C++. But both of them are going to behave exactly the same. Let's start off by creating a pawn. So I'm gonna create a blueprint class, and I'm gonna make it a pawn. And then I'm just gonna call it BP_ball pawn. And actually what I'm going to do too is, just to make this a little bit more organized, I'm gonna create it in a folder. New folder, characters. Okay, so we're gonna move that here. Okay, so now, how are we gonna start this? If we double click on the pawn, I'm gonna drag it here, we notice it comes with a default scene root. And that's all there is. So the first thing maybe we can get started with is getting a material to this pawn. So if I drag this pawn in the editor, or even before I do that, if I delete this, one thing you'll notice is if I start playing, we notice that I can move up and down, but I haven't really programmed anything to get this to work. And the reason you're able to move when you hit play is if I hit F8, what we'll notice is this is actually the character I'm possessing right now. It's the default pawn class. So if you don't create a pawn, or if you don't have anything in the editor, what it's gonna do is it's gonna create a default pawn, and it's gonna assign key bindings to that default pawn. It's gonna use the WASD key characters for your movement. And this, so let me stop the game. We notice these are all the actors in the level, but once I hit play, we notice that it increases, and these orange ones are the ones that get created. So we have our default pawn that gets created. We'll also notice that a default game mode gets created as well. That in that default game mode, the character it assigns is, where is the character? Oh, there we go, the default pawn. And that's the one we're possessing right now. So if I hit F8, I'm possessing him. Oh, F8. I'm possessing him, and then if I hit F8 again, I cannot possess him, and then I can see this is in fact the character that we have. And one thing we notice is this, so this is a default that gets created. In this default, we have these mesh components. So everything that's inherited is coming from the C++ side of things. So the collision, we get a default collision, we get a mesh component, we get a movement component. We're not necessarily going to follow this hierarchy, but we're definitely going to use a mesh component for things. So I'm going to stop, and now we're going to go into our BP ball class. And then under the scene root, I'm going to create a component, and I'm going to say this is a static mesh component. So now we have a static mesh component. So what does a static mesh component do? Well, it actually does a lot. So if we click on the static mesh component, these are all the properties that a static mesh can have. So there's variables, there's a transformation, and then the thing we're going to use is this static mesh here. So this static mesh is referring to the thing you'll see in the editor. So if I were to do a sphere, for example, let's see, static mesh sphere. When we click on our sphere, it will say, okay, what's the material for that sphere? So for now, I'm just not going to have it a material. Oh, one thing too is the static mesh is really huge. So I'm going to scale it down by half. Yeah, let's do that. Let's do half. And now we can really see what's going on with our ball. I think half is maybe too big. Let's do 0.4. Okay. So now we have our static mesh. So if we hit compile, we hit save. Now if we drag our ball into the level, we'll notice that we still don't have control over our ball. But our ball by default will have collisions. So I can't hit the ball, or I can't move it. So one thing we can do with this ball is, let's see, let's assign a material. It doesn't really make that much of a difference, but it makes it look nice. So the material we're going for is Martini, I think that's what it's called, cam material. There we go, yeah. Let's save that, just make it look a little bit nicer. So one thing too is we want to possess this character, because right now, if we hit W, I'm still possessing the default pawn. I'm still possessing it in here, the default pawn. So we want to possess this character, and we can do that by saying, if we go to this character, or if we go to the blueprints, under the pawn section, we have this auto-possessed player. I'm just going to say auto-possessed player 0. So that way, instead of it possessing the default pawn, it actually possesses our pawn, or our pawn. So if I hit play now I can't hit anything. I can't hit any of the movement keys, because currently our character doesn't have any movement assigned to it. Just to show that I'm actually possessing him, I'm gonna do F8. I'm gonna scroll out, and this is our character possess. It's the same viewport, or same point of view as the ball. So let's see. So we have our static mesh. So what I'm going to do is I'm going to make it so that there is physics applied to it. The thing responsible for physics is a static mesh. So under the static mesh, there's a simulate physics. So I'm just going to check on that. And let's see if that simulated the physics. So if we go here, we hit play. Now, the ball definitely did fall. Let's see, so I wonder, okay, so it floated. If I hit F8 to not possess the character, we notice the ball is now sitting. So one thing I want to do is I want to add a camera to this component, or add a camera to this ball. I'm going to select the static mesh, and then I'm going to do camera component. And then we're going to give it a camera. But even before that, one thing I forgot is we're going to make this a third-person point of view. So we want to add a spring arm component. So we're going to have a spring arm, and I'm going to take the spring arm and then parent it to the static mesh, and then take the camera and then parent that to the spring arm. Is the spring arm parented to the static mesh? There we go. So now we have this nice hierarchy. And the spring arm is this laser thing. It determines the distance and the direction of where the camera is. And then the camera is underneath that. So if we take our spring arm, we notice our spring arm has a bunch of properties. One of them being the distance. So if I do 420 units, the camera gets further. It's a little bit hard to see. So if I do 300, like 350, it should get closer to the character. And we notice the camera gets shoved in a little bit closer to the character. So let's save that. And now let's see what happens. So now that we have all our component hierarchies, if we hit play, we notice now we have a point of view. We now, because of the spring arm and the camera, now we can actually see our character falling. Very cool. So now what I want to do is I want to add some simple movement to this character. So to start off, I want to first assign key bindings to this character. So how are we going to do this? So we're going to go in the project settings tab. So you can find this in edit, project settings. So now in the project settings tab, we're going to go into input. And in input, there are two sections we have. We have an action mapping and an axis mapping. Action mapping is responsible for one-off key presses. So for example, if you hit W or if you hit the spacebar, you'll jump. Or if you hit some random key like X or something to interact with a light bulb or something. It's more of like a switch, really. Whereas an axis mapping is something you can just hold down and it will constantly call this function. So to start off, I'm going to do an axis mapping. And what I'm going to do is I want something to make the ball move forward. So I'm going to call this, you can call this anything. I'm just going to call it move forward. But really it's not necessarily moving it forward per se. But rather, actually, it wouldn't be moving it forward. It would be moving it forward or backwards, really. And the reason I say that is because we have some scale value. And we're going to take a look at the scale value later on. But I'm going to assign it, for now I'm going to assign it with the key press W. So what happens now? We have this key press W and we have a scale value. So do we use a scale value? Well, of course we do, because that's why it's there. So let's go into the ball. And one thing I'm going to do is we notice the ball or the blueprint itself has a bunch of things we have. We have an event graph, we have a construction script, we have a bunch of variables that we just assigned. So in the event graph, we'll notice it takes us to this small graph. Let me minimize this. And what I'm going to do is I'm going to say, so remember that in our input, our project settings, we have this W key under the axis mapping. So I'm going to say axis mapping, or I'm going to say move for, I'm going to actually use this name. So I'm going to copy this name and then I'm going to search for it in the blueprint. So if I'm going to search, and now we have an axis event and an axis value. So when we click on this axis event, now it gives us a blueprint. So what I'm going to do is I just want to see what's happening. So if I do print string, so we have our print string, and I have no idea what this axis value is doing. So let's just print it out. We want to see what's going on. So if we play, now we have a bunch of zeros. So what if I press W? We notice that those zeros become 1. What if I press S? Well, nothing happens. So what I'm going to do, this is why I called it forward and back. Or this is why I'm going to show you why I called it forward or back. So right now, we notice that if I press play and I just press W, that will in fact turn this access value, return value to 1. That one way you can think about it is if you were to press W, it's some function where if W is pressed, it will return 1. So now I'm going to complete the access mappings. So I'm going to do another one, and I'm going to do one with S. And now S is usually associated with moving backwards. And that's exactly what we're using it for. Actually, before that, just in case you didn't want to use W, like you wanted to use the up key, I want to make it so that you can use either W or up, and they would do the exact same thing. And so we're going to continue with S. So S will have, we do our S key, we do -1. And then if we do our downward key, down, and then that will also be -1. And let's test it out. So if we hit play, hit W, it's +1. Hit the up key, it's also +1. Hit S, it's -1. Hit down key, it's also -1. So this is like an important part. It's these project settings that we have, these bindings, they're not necessarily making the thing move. It's just taking it as a function and then returning whatever number you're specifying in here when that key gets pressed. Yeah, so we have W up. So another one I'm gonna do is move forward and backwards, and now we're gonna do move right or left. And this is exclusive R, so it's either you're moving right or you're moving left. You can't move both right and left. So for the right, I'm going to use D. Where's the D? There we go. And then I'm going to return a +1 for that. So when you press D, it's going to return +1. And I'm going to do right key, right arrow. There we go. And that's also going to be +1. And then if we do A, the A key, that will be -1 because it's going the opposite direction. And if we do left key, so we have our left key, and that will be -1. Okay, so now let's just test it out. So right now this function, all this function calls, since this function is called move forward or backwards, the only thing it can call is everything in here. So I want to add another node because I want to call everything in here as well. Everything, so minimize this. I want to call everything in here as well. So what I'm going to do is, what did I call it? Move right or left. So I'm going to copy that from the project settings. I'm going to take that, and then I'm going to take the access event and print that. And I'm going to do the same thing, print string. And I'm going to put an access event in here. So I'm going to compile that. I'm going to save that. And now let's run it. So if I hit D, it's +1. Hit A, it's -1. The reason there's like this 0 is because it's coming from this. It's going 0, and then it's going to call this function. So hit D, it's negative. So now we have all our access events in here. And then if I hit the right key, it's also same thing. So right now we have this. One thing I also want to add is I want to add a function I want to add something to handle the camera movement. So this is going to be a turn event. So I'm just going to call it, again, these names are just, I'm just calling them turn because that's like what I think of when I think of this event. But it's just supposed to handle it's supposed to handle the event for when you move your mouse right and left. So I have it set to 1. So now, if in the blueprint itself, I'm just going to copy this name and then go to my blueprint, and then I'm going to paste this name. And now we have this turn access event. And then all I'm going to do is a print string. I just want to see what's going on. I want to see what my project settings is actually doing and how it's affecting my blueprints. So in the project settings, we have this mouse X. So now what I want to do is I want to take this, and now I'm just going to move my mouse left and right. So I'm moving it. You can see sort of some numbers, some negative numbers. We noticed that we didn't even have to put a -1 for this mouse X. Just by moving your mouse to the left, it will give you a negative number, but moving it to the right, it will give you a positive number. Or is that right? Yeah. Yeah, that's right. And then I'm going to do the same thing, but for the lookup. So I'm going to add one more, and then I'm going to call it look up. So now, and this is supposed to handle the situation for when you move your mouse up and down, or like forward and back, I guess. If you think about it as a 2D plane. Forward and back. So I take my mouse Y, so in the positive Y axis and then the negative Y axis. So we have our 1, we have our turn, we have our lookup. So now if we go, I'm gonna, again, copy this name, because now that I put it in the project settings, I can take it into the blueprints. And I don't need to save or anything. So I have our print string in here. And the only reason I'm putting the print string is just to show you that, like showing you what's happening currently, instead of just doing a bunch of things and then like hoping you understand as it goes. So we have now W, and now if I move the mouse up and down, we notice it's the same effect as when we did the moving right and left, except now I'm moving the mouse in the positive Y direction and the negative Y direction, if you consider this like a 2D grid. So now, so far, we have all these projects in our bindings. All we have is one keynotes is that if I don't press anything, if I just put play, the default value will be 0. If I press W, it will be +1, S -1. So if you put some value, it will return that value. So that's the significance of these scale values. You know, if I change this to 2, then in my project settings, if I put play and I put W, it's 2 instead of 1. So just think of it as, okay, I have a function. When I press that function, to set up this function, I have to go to my project settings. I give it a name, and then to call that function, I have to use these inputs. So when this is pressed, this is the return value. When up is pressed, this is the return value. So you have the action or the key when it's pressed, and then what should it return? And it's always going to return a number. It's not going to return anything else. So it's important to note that currently none of these keys that I'm pressing are actually moving the ball. You know, like if I put play, there's nothing moving the ball. You know, it's just printing strings. So now we're gonna go into how we can actually move the ball. So now let's start with the turn, because I think it's the easiest. So if I hit the spring arm, or if I click on the spring arm component, okay, there we go. We'll notice that moving the camera is essentially rotating it this way. Oh, why is it? Okay. Okay, so moving the camera is essentially taking this thing and rotating it. And one thing we notice is the name it's giving it is a yaw. So right now I set it to 0, 0, 0. So let's just do that. Let's just We know that moving it to the X is equivalent to just taking this thing and then moving it to the right. I'm just going to put it there. And I'm going to go into the event graph. And let's see. In the turn, I'm just going to say yaw. And now there's one specifically for the pawn where it says add controller yaw input. So I'm going to click on that. And we notice that it takes in a value. This value corresponds to the value we're returning in here. So if I take this axis value and then just put it into the value, I can have it plugged into different nodes, so it doesn't really matter. This print string is just for debugging purposes. You don't need this, but I just wanted to have it there to show you what's going on. And then I'm going to add an execution pin. Like that. Okay, so we notice that we want to get the camera to move, or we want to get the camera to rotate. So we know that we need this yaw input. And compile that, save that. And now we're going to the event graph. I was just testing this out really quick. And so we know that we're moving the yaw. And so I'm just going to put yaw. And then we have this result. So I'll use that result. And I'll take that result in here. When I was testing this out, it wasn't working the first time. And it was because I forgot that in the spring arm component, since we want to make it so that the mouse is rotating it, so it's an effect that happens, it's an effect that happens from the spring arm, and we can see that because it says the target is the pawn. It's an effect that happens in the pawn, sorry. So in the spring arm, we have this at use pawn control rotation, and that will give us the ability to actually, because the moving to the right and left is affecting the pawn, and we're going to use this add controller yaw input to actually use those controls. So we're going to save that. We're going to do it again. And now, okay, there we go. And so quick recap. All I did was add the control yaw input, and I used the axis input turn. And just to be consistent, I'm going to do a print string. It's not going to really affect it that much. And let's alt and put conversion in here. This is just for debugging. But one thing we notice in here is if I hit play. Oh, there we go. Forgot to put the value. Okay, save. I hit play. We notice that when I go to the right, it corresponds to positive values, and then when I go to the left, it corresponds to negative values. This, to me, feels opposite to how the mouse is actually moving, because when I move to the left, it's moving the characters to the right. And so because that feels a little bit weird, what I'm going to do is in the project settings, instead of me saying the turn value is 1, I'm going to say the turn value is -1. This just makes it so that it feels like when I move the mouse to the right, it moves the character to the right, even though that's corresponding to a negative value in the print string. So just to make it a little bit more natural. So now if we go to the BP sphere, we have this axis value. And what I'm going to do is we have a print string. So yeah, so I'm going to do the exact same thing. So if I were to go to the viewport and hit the spring arm, and we notice that we want to look up, we're essentially wanting it to rotate in this direction, like up and down. We're wanting the camera to rotate in that direction. Sort of to show this physically, we want the camera to go like this, basically. So now we're going to use control yaw input. Okay, so the way we can do this is we notice it says pitch in here. So what we can do is in the event graph, at the point where it says lookup, we know this gets called when I move my mouse in the positive y-axis and negative y-axis if it's the 2D grid. So what I can say is, I'll write just pitch, and then there's add controller pitch input. So in here, I have this settings here, so add controller pitch input, and now I'm gonna plug in, it takes in a value, so that value will just be the axis value that I'm passing in. So if I hit play, look up, now I can look up and I can look left and right. Pretty cool. Okay, so we used these two. So we covered these two in our project settings. Now we need to tackle the move right or left and then move forward or back. So how are we gonna do this? So if I take my play button, okay, so if I take my pawn, so we know this is gonna be responsible for moving forward and back. So how are we gonna actually make it move? Because right now all we're returning is 1. So the way I approach this, what we can do is just look at our add functionalities. So there's add angular impulse, add force at location. So the general approach, or the approach I took, is I just tested out these functions to see which one feels the most natural with the physics applied in our static mesh. And I found that the add force actually works the best. So we have this add force, and now, so this add force is responsible for the movement of our actor. It's not necessarily the project settings that we have in. It's just returning 1 or -1. And we notice that it's expecting a constant force. It's expecting a constant force over time. So that force, let's see, so I'll actually get rid of this print string because I'm gonna connect these together. So this is the main thing. I want something to add the force. So what we can do is we can make a vector, an approach you might have thought of is take this axis value, which will be 1 in the case of the character moving, or in the case that the player pressing W. So we can just try plugging that into the X value, and then taking that return value and then plugging it into the force. So when you press W, the force vector will be 1, 0, 0. So if we compile that and save that, we'll notice that if I hit W, so it's kind of moving. Actually, it doesn't really show. And that's because the value of moving it forward is so small that it isn't gonna affect the value. So there's 2 ways we can approach this. Instead of this making it 1, we can make it something like 500. But rather than doing that, I'm just gonna make it 1. And in the blueprints, I'm gonna say vector times float. So in here, I'm gonna, instead of plugging this directly into our add force, I'm gonna plug it into our value, and then I'm gonna multiply it by I can multiply it by 500, or I can test this out. So I can put this directly back and then compile this and save that. And let's see. Ooh, still nothing. Let's see. So it still doesn't show that the ball is moving. And so what we can do is, I believe that this is because the mass of this ball is way too big. It's 190 kilograms. So we could try changing this weight, but rather than doing that, I kind of like it to have it that weight. So I'm gonna instead use this checkbox here, this add acceleration change. So if it's true, the force is taken as a change in acceleration instead of physical force, i.e. mass will have no effect. So this mass in here in the static mesh will have no effect, and that's what I'm wanting. So I'm gonna hit check mark, compile, save. I'll hit W. Oh, I'm pressing the wrong key. I was pressing Q this whole time. So now, just to double check if we don't have this mass acceleration, and we hit save, and then we go in. Yeah, it doesn't, yeah. It's because this mass is so big that this force is like tiny compared to it. So if I hit check mark to this acceleration, and this is important because we're gonna find that this is gonna be something we're also gonna have to do in the C++ side. So we have this add change acceleration, so we hit save, and then we hit play, and then we notice it's going forward when we press W, and it's going back when we press S, or alternatively when we hit the forward key or the backwards key. It does the same thing. So really the highlight is this node in here. So because I'm using this add force, it's responsible for moving the character forward and back. But there is a problem with this approach in that, for example, if I were to hit W, we know it's going forward, and if I hit S, it's going backwards. But what if I rotate the ball like this and I hit W? It still goes forward because it's relative to the world, or it's relative to its x-axis. So there are some situations where when we orient the ball in the Y orientation, pressing W should effectively move the ball in the Y-axis instead of the x-axis. So it's not necessarily that, move forward corresponds to the x value, because depending on where your ball is oriented, it could be that the y-axis is the forward direction. What we can do instead is, instead of making a vector and directly plugging in an x value into that as our axis value, what we can do is we want to take wherever the camera is oriented, take that vector, multiply it by our axis value, multiplied by like this number here. One thing we can do is we can, instead of just putting a constant 500, I can promote this to a variable, and then I can just call this variable, so let's compile that, save it. And this variable, what can we name it? We can name it the ball speed, just to be a little bit more expressive. So we have our ball speed here. And then I just set that to 500. Instead of just, it's the same thing, it's just a little bit more readable this way, I think. So we have this make vector. Okay, so instead of making a vector, what I'm going to do instead is I want it so wherever the camera is oriented, so get forward vector. Like I want where the camera is oriented. So if I say get forward vector, we have a bunch of things, but the only one that really has any association with the camera is this transformation get vector camera. So if I click on that, we have this node now. All I'm gonna do is I'm gonna take that node and then I'm gonna plug it in here. So if I do that and then multiply it by the speed, so wherever the camera is oriented, it will be that. I still need to account for this axis value before I do that. So I still want it to account for +1, -1. So for example, if I just compile this and run this and just orient this, okay. We notice that it doesn't even care about the axis value. It's just gonna move forward. I'm not even pressing anything at this point. So we don't wanna forget about our axis value, because we don't want it to move. We don't want it to move if we're not pressing anything. And if we don't press anything, it's gonna be 0, so it won't move. So we have our camera, and we're gonna say vector times float. So in the case that you're not pressing anything, plug it into this vector here. Oops, sorry. Take this axis value and plug it into the float input right there. And now I want to take the camera direction and then plug it into this. So it looks a little bit tied up. So let's just go through this before, or let me just plug this. Okay, so let me just go through this. So take the camera, wherever the camera is oriented, and then take that vector, multiply it by the axis value. So in the case that you're not pressing anything, the axis value will be 0. So it will be 0 times whatever vector your camera is, whatever your camera vector is. So it could be 1, 0, 0, or it could be 0, 1, 0. But it doesn't really matter if you're not pressing anything. The result vector should be 0, 0, 0. And that's what the force should apply. It should apply a 0, 0, 0 force. Because we shouldn't have a force if we're not pressing anything. Okay. After that, this result will be really small. Like a 1, 0, 0 is a small force. So what we could do is just change this to 500 instead of 1. Or we can take that result, keep it as 1, and then just multiply it by some number. In this case, I multiplied it by a ball speed, which is just randomly I picked 500 as its unit because it felt the most smoothest, or it felt the smoothest. With that, now we have, like if we think of a situation, we don't press anything, this will be 0 times some vector, which will be 0, times some other value, 500, which will also be 0. In the case we press 1, and it's going to be 1 times this camera vector, and then that times some ball speed value. So it's going to be, instead of 1, it's going to be 500. So if I compile this, save that, if I run this, we have this value here. One thing we can do also is, I kind of explained it, but I think it does better to just see. So if I do a print string in here, right before I put in the value into this add force, I just want to print what that vector is. Just to show you, instead of, I think it does a little bit better than trying to explain it. So it's a little bit messy, but all I did is I took this force value right before I added it to this, and then I printed it in here. So if I'm going to compile this, I'm going to save that, I'm going to run this, and now we have our vector. So when I press W, it's going in this direction. If I press S, it's going backwards. If I orient the camera this way, I hit W, it's going this way. And if I hit S, it goes backwards. So I'm going to get rid of this print string. I'm going to make this a little bit tidy because it's slightly messy. But what we have done in here is add force. Yeah. Like all we had done is like multiply that value by take the axis value and then multiply it by a vector, and then take that speed and multiply it. So if I highlight all these nodes, all these like multiplication nodes, and I can collapse this to a function. So we have this nice function. And now what I can say, I'm gonna bring this camera forward, and I can name this. So the first one, this A variable here is a vector. So it will be the camera direction. And then for the V, it will be the axis value. And that's coming from the project settings. So in the case, press W, it's 1. Press S, it's -1. The output will be a return value. So that will be the force vector. That's what this function is returning. And then it's taking that force vector and then plugging it into the force node in here, or the force input. If I click on this new function, I want to name it. Let's see. One thing I could also do is make this pure. So I want this to get called. I want this function to get called whenever this function will get called. All pure means is when this function gets called, the move forward or back, immediately call this function. In the blueprints, okay, there we go. In the blueprints, for some reason it made 3 blueprints. Let me get rid of these 2. under the function section, I have this new function. So I can rename this to get movement direction. Movement direction. Because that's like what it's doing. When you're multiplying that value by the camera vector times the axis value, and then taking that value and then multiplying it by some scalar value, it's essentially what you're doing. So if we save that, and now what we can do, we have this a little bit nice and compact. This move right will essentially follow the same approach. We actually don't even have to do a lot of the hard work, because the move right, the only difference is, instead of us calling it get forward vector for the camera, so I'm gonna take this get movement direction. So I'm gonna right click, get movement direction. And in here, what we can do is we can take the axis value and then plug it in like we did with the move direction. And let's delete this. And for the orientation of the camera, since we're getting the right or left, like we're trying to move it right or left, all we have to say is get right vector. And the get right vector will have a camera associated with it. So we have our camera, and we can connect this here. And the static mesh will be, so we're going to say add force, static mesh, get rid of the static. And then in here, we can say, get rid of this, and then plug the static mesh in here. And take the vector from the camera, and then take the axis value from the right or left. This is the exact same thing as what we did with the move forward. It's just with the move right, instead of us taking the forward vector for the camera, we're taking the right vector. And then we're going to do acceleration on. And compile it and save. So we have our camera. We can move right or back, left or right. And depending on where our camera is oriented, it will move in that direction too. So that's perfect. So this really, it concludes our movement for the blueprint side of things. If there is issues, you can always take that vector. You can, if you're wanting to debug this, you can always do an print string in here, and you can just take that node in here and just call it in here. So just if you're wanting to actually see what's going on behind the hood, under the hood. So we have our vector going this way, forward or back, right or left, and then we can see that vector corresponding to those changes. So now we're going to do the exact same functionality, get this ball moving, but instead of us creating it in blueprints, we're going to create it in C++. First thing I'm going to do is I'm going to say a new C++ class, and like the blueprints, I'm going to make it derived from a pawn class, and then I'm going to call it ball character class, or ball character CPP. And now I'm gonna create the class. So as it's compiling, we're gonna wait for it to compile, and what we're gonna do is essentially translate everything we did in blueprints verbatim into C++. Okay, so now that it compiled, notice it made both a header file and a CPP file. Our ball character CPP.h and then our ball character CPP. Yeah, that's fun. So the first thing we're gonna go for is similar to our, or exactly the same as our blueprints. We're gonna want this hierarchy of components. And we're going to do this all strictly in C++. So we're going to go back to the code, and let's see. So in the components hierarchy that we have in Blueprints, we notice that some of them give us hints of how we're going to write our C++ class. I'm just going to use this as reference. So it says in the description, the static mesh component is used to create an instance of a U static mesh. So we know that we need some U prefix in our static mesh. And it's pretty similar to the spring arm and the camera, as well as the default scene root component. So in our C++ class, so we're gonna make our components. So I'll just put it in the public section because I don't want to worry too much about it, but you could have it in the protected section. So we're gonna have class. We're gonna forward declare it first because we want to tell the compiler these components exist. And in the CPP class, or in the .cpp file, we're actually going to create it. One thing we want to do before that though is just to clean this up a bit. I discovered this early on, or I discovered this later, is that all these events that we have in here, this add force, this add movement and right, movements and moving the mouse X and left and right, they're all corresponding to input movements. So instead of having it in an event graph, what we can do instead is we can make a new graph. This is just stylistic. So we can have this be an input graph. Just a little bit of cleanup. There we go. What I'm going to do is I'm going to take all the things that are responsible for input in our game, and then I'm actually going to paste that into the input graph. And the reason I did this is because I want to highlight that in the event graph now, so we have all the stuff for our input graph. I want to highlight in the event graph now, there isn't none of these functions we're using. The event begin play, the overlap, the event tick, and they're also grayed out, so we're not really using them. I'm bringing this up because we notice that we have these event graphs functions in our CPP as well. So since we're not really using the begin play, I'm just going to delete it. Oh, before that though, we're going to install a couple of extensions. So make sure you have the C++ IntelliSense extension from the marketplace. Another thing you want to do is make sure, just to make things easier, we're going to download the UE4 snippets. Do I have it installed? Unreal Engine 4 snippets. Snippets for working, this one. Snippets for working for Unreal. And this makes it easy because right now it has a bunch of acronyms. So if you press this in, it will give us the code we need for printing things. I just find it easier to work with when I'm using this snippet. So the C++ IntelliSense, and then the UE4 snippets, and another one is the C++ helper. Let's see. There we go. So another one is a C++ helper. So this helps for writing function declarations and function definitions as well. So we're going to be using that to make things quicker for us, or easier for us. And so I went through and deleted the begin play and the begin overlap. So I'm going to go through that in the CPP as well. I'm going to delete these. Undo. I'm going to delete these because I'm not really using the event begin play, nor am I using the tick event as well. So I'm going to delete these. I'm going to use a player input component because that's what we're going to use for the key mappings. And since we're not using the event tick, I'm actually going to set this be ever tick. I'm going to set this to false. I'm going to save that. And yeah, so get rid of this. Let's see, clean it up a bit. We have our constructor, we're going to use that. We have our setup player input component. I'm going to create the components here. So I'm going to say class pointer. The first one I need is a uScene component. So uScene component. And then I'll just say it's a scene component. So the first thing I'm gonna do is I'm just wanting to create the components so they're exactly the same as the one in the blueprint class. So having this hierarchy essentially. So the first one is a scene, the second is a static mesh, the third is a spring arm, the fourth is a camera. So let's go through that then. So we have our scene component, and then we need our static mesh. Just make space, yeah. Class pointer static mesh component, static mesh, and class pointer spring arm component, spring arm. I'm very creative with my names. Spring arm. And class pointer so we have camera component, static mesh, scene, and then we need camera component. Camera. So by doing this, I'm essentially trying to set it up so that we get the same hierarchy. We notice that these 4 components are supposed to be a direct translation of the things we have in blueprints, these 4 components. So the first order is we're gonna first create them, and then we're gonna structure them so it has like that hierarchy. One thing we can also do is, just so that we can edit it in the editor, you don't need to do this per se, or I guess you need a U property, but the specifiers I'm using, you don't really need to use these specifiers. Oh, I have a better idea. What I'm gonna do is I have these 4 components, so I'm gonna give them all specifiers. So I'm gonna do that, and U property, and I'm gonna say it's edit anywhere. Edit anywhere. And then I'm gonna say it's blueprint read write. And then you could give categories to it if you want to. Edit anywhere, blueprint read write. Yeah. And now we're gonna save that. And now we're gonna physically create the components. And so what I'm gonna do is I'm gonna create these components in the constructor, in the class constructor. So this constructor gets called whenever you drag the thing into the viewport. So we're gonna go through that in a bit. So what I'm gonna do is first, I'm gonna create everything. So let's see. I'm gonna get rid of this plugin. I wanna see the names I gave it. So let's see, the first one was scene component. So I'm gonna say scene component equals create default subobject, and then the type. So this is a function template. So the type it takes in is the thing you're trying to allocate memory for. So in this case, So in this case, we want a scene component. So we're gonna say scene component. Like that. And then it takes in a string as in the constructor it takes in the string as a function argument. So I'm just gonna say it's a scene component. Doesn't really matter what name you give it. I even misspelled it, but yeah, okay. And we're gonna save that. And we're essentially going to do the exact same thing, but for the mesh component. So mesh component, and then we're gonna do mesh component. and yank. So we have mesh component, we have scene component, we have spring arm component. Is that what I named it? Let's see. Spring arm. Yeah, it's just spring arm. And then in here, the type is not a scene component. The type is actually a use StaticMesh component. So I'm going in here, I'm gonna copy this, I'm gonna put it in here. There we go. And in here, we're gonna do the same thing. Use StaticMesh component. There we go. All classes get prefixed with a U in Unreal. So we're gonna save that. So we have 3, scene component, mesh component, spring arm, and then the last one's the camera. So we have our camera component. We have camera component. And then let me just copy this and paste it in. Okay, so we have camera component. Let's delete this. And so we're creating it, so it's camera component. So now, let me get rid of this. So these are the components we created. So we declared them in the header file, and then we're creating them in the CPP file. One thing is that Unreal doesn't know these types because they're not included by default. So we have a scene component, so we're gonna need to include the header file for the scene component. So the header file for the scene component is this component/scene component. It could be included with it could be included in the header file. I'm not necessarily sure. Like, it could be included in this game framework pawn.h or the core minimal, but I'm not entirely sure. They're just like adding another one. Since there's an include guard, if it's added once, it won't add it again, so you don't have to worry about that. So we added the scene, and then we need one for the mesh. So the one for the mesh is component, static mesh component, and we're gonna need one for the spring arm and the camera. The one for the camera will be spring arm component, and then the header file. So this is the one for the spring arm. And so we have the spring arm, and then we need, the last one would be for the camera. This is the one for the camera. So these are the ones for our components. So far in our constructor, we're just creating the components. We're not doing anything to them. So what I'm gonna do is I'm gonna compile and pray it works. Oh, okay. I made a silly mistake. It was class using component pointer. It's not pointer using component. I bet. And then I did that for all of them. Because it's a spring arm. It's the address of a spring arm. And let's see. There we go. Let's save that. Now it's compiling. And okay, use spring arm component, unrecognized type, use spring arm component. Use spring arm. It's probably a spelling error. Oh, yeah, it is a spelling error. Okay, use spring arm component. There we go. So even if you forward declare something that doesn't exist, I don't think it will work. So now we fixed the spring arm. Okay. So undeclared identifier scene component. Oh, okay, I think I misspelled this. Me and my spelling. Okay, so yang. I'm gonna copy this to in. And then mesh component. I think, did I named it StaticMesh. So I'm gonna erase this. And it's a static mesh, I think. Yeah. Let's save that and copy it or build it till. Okay. So now it's just the camera. Camera. So what is it complaining about? Create default invalid. Create default sub. It might be just line 17, undeclared camera component, undeclared identifier. Oh, it's probably a spelling. Oh, it is a spelling. My bad. Camera component. There we go. And save that, and then build it. Hopefully this is the one. I feel it. Okay. So compile is fine. And so now I'm gonna compile this in the editor, make sure it's working, and then we'll see what the result is. Okay, so it compiled, and now let's open the editor. So what I'm gonna do in here is I'm gonna take this CPP class, and what I'm gonna do is I'm gonna make a child class that's a blueprint class. And the reason I'm doing this is just so that I don't have to bother assigning the materials in the C++ class. Instead, I can just assign it in the blueprint class in case I just wanted to change it. So I have the ball class, and I'll put it under the characters folder, and then I'll just call it BP, and then I'll do BP underscore my ball character CPP. It's a mouthful. Okay, so this could happen where you created the components, but it doesn't register all of them. So in our case, in our case, we have created a default scene root in our code. So we have our scene root, scene component, but it didn't register in the compile time. So one thing we can do is we can compile it again, see if it refreshes. If that doesn't work, what you can do is, so let's see, let's close that. Let's go into our ball and then open it. Okay, so it didn't register. What we can do now, what we can try to do is essentially just close the editor and then open it again. And we'll see if that refreshes it. So we're gonna open it. Okay, so we're opening the project again. And hopefully on the second time, it will refresh all our components. So let's see. So we have our BP character as CPP. We'll close this, open it, and we'll dock it there. And we'll open the blueprints. And there we go. So now we see our scene component and then all our static mesh components. And again, with the hot reload, sometimes it's hit or miss. Sometimes it refreshes right away. Other times it freezes and it doesn't know what to do. So in this case, now we have our components and we have all these properties in here. And these properties, we can edit them because in our code, in our header file, we specified, we gave it these specifiers. Had you not given these specifiers, I don't believe you would be able to see this drop-down menu, but you would be able to see the components in here. So we have the components, and again, all we did in our CPP was in our constructor, we created these components in here. And that's all we did so far. So just created it. And we know it's from C++ because it says inherited. So it's inheriting it from C++. So one thing we want to do is, like our blueprint class, we want to make sure we have this hierarchy, which right now we don't. So we're going to make sure we have that hierarchy first. So in our constructor, we're going to set up attachments. So if we search root component, this is, if we do F12, this is the default root component, and it's provided through the actor class. It doesn't show up in the component list that we just saw. So what I'm going to do is I'm actually going to say the root component, the root component is actually equal to the scene component we just created, because they're both of type scene component or uScene component. So I'm going to say scene component. So this is just saying, okay, make the scene component the root. And then from there, we can start doing the attachments. So we know that the mesh component is connected to our scene component. So we're going to say StaticMesh. And then we're going to do, since it's a pointer, we can do two things. We can either dereference it, like that, and then call one of its members with a dot, and then set attachment. We could do this, and then we can say set attachment to scene component. So attach the mesh component to the scene component. This is a little bit, it's not the cleanest way. Another way you can do this is, instead of doing the dereference and then the star, what you can do is use the arrow operator. I think also the function is not set attachment. I think it's set up attachment. Yeah. So set up attachment. There we go. So we're attaching the mesh component. We're attaching the mesh component, the static mesh to the scene, which it is by default right now. But then something that's different is we're going to attach the spring to the static mesh and attach the camera to the spring. So we're going to say spring arm component. Or what did I call it? Oh, I called it spring arm. Spring arm set up attachment to mesh component, static mesh component. And then from here, I'm going to copy that, I'm going to paste that. I'm going to say, okay, so the spring arm attaches to the mesh, and the camera attaches itself to the spring arm. So camera setup attachment. And then this is a little bit different. So if we look at the arguments in the setup attachment, if we do F12, it says the first argument is the parent, and the second argument is the socket name. By default, it's going to be socket name _ none, and that's fine. But if we go into the camera, the socket name is actually going to be the socket name of the spring arm component. So in this case, we're going to say spring arm component, or spring arm, and then the socket name is going to be U spring arm component. And then we're going to call a static variable from there, I believe. So socket name. There we go. We didn't need to do this for these two. It's because the default was fine. But for this, we have to specify. I believe we have to specify that it is a socket name from the spring arm. And doing this piece of code in here is essentially setting up our hierarchy. So static mesh attaches to the scene, spring arm attaches to the static mesh, camera attaches to the spring arm. And so we'll compile that. Okay, it failed. Let's see. So undeclared identifier scene component. Scene comp. Oh, I misspelled it here, but I also misspelled it there. So I'm actually just gonna misspell it there. And scene component. I'm gonna take that out. Use spring arm component. Did I call it camera component? Oh, okay. A lot of spelling errors. So component. Can't remember the names I gave. Okay, so and then root component. Okay, so I think that fixes it. It's just some spelling errors. So we're gonna compile this. Okay, so I compiled. And now we're gonna do an editor build, and hopefully we can see this new hierarchy. So it's compiling. Okay, so I heard the bell. Okay, so now I'm gonna take the ball, and we'll see, double click. Okay, so it didn't refresh because it doesn't show us our new hierarchy. So again, I'm gonna have to close the editor and open it again. Another thing you could do is you can try reparenting it. So going into the C++ and then make a new blueprint class and then do that again. But in case you already have some blueprint class and you don't want to like redo the blueprint class each time, you can try just closing the editor, and usually that fixes it. Because closing the editor and opening it again re-serializes the data. So it will catch anything if it's screwed up on the first time out. It will catch like this loading screen. What it's doing is it's re-serializing the data to make sure if it catches anything that it didn't on the first go around. So hopefully with that, it recaught it, and it caught the attachments. So we're gonna double click. I'm gonna put this here. I'm gonna open it, and there we go, beautiful. So we have our attachments in here. So we have our nice hierarchy that we have. We have now the exact same hierarchy we do in the blueprints. So that's definitely a step in the right direction. So far we didn't do any like logic. We just are creating the components. And we're doing that by using create default sub object and set up attachments. So we can go ahead and start putting stuff in here. So for example, the static mesh. The reason I made it a blueprint is so that we can just like specify from here instead of specifying it in code, the path, because it needs to know the path of the sphere, and it's easier to do it in the editor than it is in the Visual Studio. And so the material, what was the material I went for this? I think for this, I think I called it bone white, or yeah. This should be available to you, like even if you make a empty project. Okay, so we have our camera. Woo, that's huge. Okay. One thing, maybe a challenge activity, is one thing I'm gonna change the scale so it's 0.5, but try figuring out if you can do this in C++. See if you can make it smaller in the code instead of in blueprints. So now I made it smaller. But so for example, one thing I would also have to do is I would make it so that the auto possess, so in our BP ball character, I would have to make it under the ball section. I would do auto possess player 0. We can do this in the blueprints, but I just wanted to show you a other alternative. Again, this auto possess is just like you use this, but normally you would have this logic setting who possesses the player in the GameMode class. But we're not going to touch the GameMode class in this video. so it doesn't matter. But one thing we can do is a nice trick we can do. It's not necessary, but I thought it was cool, is that you can do an auto possess player, and then we can set that equal to e auto possess input, and then colon, and then player 0. What this does is it just sets the auto possess to player 0 in the editor. So instead of you going into the editor and then clicking on auto possess player, we have this code that does it for us. So it automates that activity. So what I can do is do a development build, see if that works. Okay, it didn't work. E auto possess input. Oh, oops. E auto receive input, that's what it's called. And then we can do a development build, see if that works. This is it shouldn't take too long to compile. Okay, so it compiled and it worked, and that's just so that we can automate a simple task we do in the editor. One thing we noticed with the spring arm is if we go in, we had it so that the spring arm uses the use control rotation in here. So we could check this again in blueprints, just like we did for the blueprint class. One other thing we can do is instead of doing it in the blueprints class, we can do it in the spring arm component class, and we can do it in the one of the functions we can use in the spring arm is we can call this be use pawn control rotation, and then we can set that to true. And what that does is it makes it so that in our editor it just ticks it automatically. So we know that one of the things we have available to us if we're in a spring arm component is the be use control rotation. So in the C++ side, the way I think about it is, okay, in my spring arm component, I use the arrow operator because it's a pointer, and I look for, one thing you could do is you could do F12, and then in the spring arm component, if you're wanting to modify anything, you can do F12, and then, so I'm gonna search for something, so I'm gonna do F1, and then I'm gonna find, so Control F. And if you're trying to find something like transformation, so we have like a scale. In this case, I was trying to find the pawn control rotation, so I just searched pawn control rotation. And there's 3 results. One of them happens to be the one that I used in the constructor, which is the be use control. The B gets used because it's supposed to identify booleans get prefixed with a B letter. So that's all I used in this B control rotation, and I set it to true. I'm gonna compile this with our new settings. So sometimes it works, sometimes it doesn't. Most of the times you have to just close the editor and open it again. So I'll do that just really quick to show that it actually modified the thing. So I don't want to save this. Okay, so it opened again. I just opened it, and then now let's look at the blueprints and open the blueprints. And we notice if we go to our spring arm, there we go, it has it ticked, and I didn't tick it or anything. So this was coming from the C++ side, like it automated this. And another thing is if we go to the blueprint as pawn, we also notice that it's setting it to auto possess 0. And this is coming because of our code that we wrote here. So because we wrote this one, it auto possesses to player 0 automatically, so we don't have to do that each time we open the editor. And then we have the spring arm pawn control rotation, which is true. Yeah. Also, this is something you would do in the game mode, so I wouldn't recommend doing this. But if you're just gonna do something really quick, it's a good example to show. Okay. So now back into the editor, we have our components. So we have in the static mesh, we could do simulate physics in C++, but for the sake of time, I'll just save it there. If we save this, okay, so we kind of have it, so it's like our blueprint now. We have a camera that's following it. If I drag this up a bit, play it, so there's physics applied to it. So now what we can do is we can do the easy ones, or the quote-unquote easy ones, which is the turning the camera left and right and then up and down. So we're gonna do that under, so this set player input component is supposed to be the one where it handles all our inputs. So in this case, I renamed the blueprints into the event input graph. In the C++ side, this input graph, like this is essentially the input graph. Like if we try to think of like a direct translation, the things I have in my input graph will be the logic I will have in my set player input component. The first thing we're gonna do is from the plugin that we downloaded, from the extension we downloaded it, the UE4 Unreal Engine snippets, I'm gonna be using this, so I'm gonna be using it right now. So I know from our project settings that the thing I set up was a bind axis. So under the inputs, I have these axis mappings. So I know in the C++ it's gonna be called something bind axis. So if I just say u bind axis, there's a code snippet. So if I hit tab on that, it gives me an autocomplete feature. So we notice from this layout that the second argument will always be a pointer to the function, which is in this case a pointer to an A-ball character CPP, which is the name of the class I gave it. So the first string argument is actually the one that we passed in from the project settings. So I'm just going to go into the project settings, and then I'm just going to copy this. Like what I did with blueprints, I'm going to copy this, and then I'm going to put it into this. The second argument is the class. So in our case, we called our class this. So whatever name you gave it. So move forward and back. And now the function. So we need to, let's first create a function. So I'm going to create it here. So void move forward and back. I'll just call it move forward because it's less things to type. I'm going to use the Unreal helper to generate a function definition. So I'm going to right click and then I'm going to say create implementation. So now we have our implementation. So the address of the function. So right now it's labeled as function, but we actually want to make it so it's move forward because that's the name of the function we just created. So essentially, when the W is pressed, it's going to call this. Also the player input component. So if the player input component happens to be a W or happens to be this, then call this function essentially. Call this function. So it says input component, but it's actually player input component. So I'm just going to say player input component. Okay. So one thing I could do to test this out is I could do a print string. So this move forward actually should take a value. My bad. So float, because a bind axis returns a value. So this function will return some number. So I can do void a float value. Okay. And we're going to save that. And then in the CPP class. So what I can do is just call this function and then just print out whatever the value is. The value is going to be coming from the project settings. So if I say uPrint string. Oh, I think I said I was gonna do the turn first. We'll do the turn, but we'll first set up the input things. Oop. So again, to get this to work, I did uPrintString, and then there's a code snippet. So I clicked on that, and then it generated this. And then I can maneuver to the next tab by just hitting tab. So I hit tab, and then now I can pick a color, hit enter, and then hit tab, and now I can put a string. So in this case, I can say value or something. So we have the color, and now notice that this is a printf. It's supposed to mimic the C functionalities. So I can say value is, and then I can do a %f for float numbers, and then I can do value here. And I can save that. Let's compile that and see what happens when I hit W. So what happens when I hit W and it uses this as the arguments, and then it calls this move forward. Okay, it failed. Move forward or backwards. Ooh. Oh, okay, my bad. This is supposed to be the name of the class. So it's a ball class. A ball class character CPP. Because that's the name of our class. It's the name of the class, colon, the name of the function you just created. So I'm going to save that. I'm going to build it. Okay, so the build was successful. And then I'm going to do an editor build. So now that it built, I'm going to go into the project. I'm going to delete this. I'm going to drag it back into the viewport. Now we're going to put play. If I hit W, we notice the value is now 1. And if I hit D, the value is -1. So this is exactly the same thing as we had in our blueprints, because in our blueprints, this axis value was either 1 or -1. When you pressed W, it was 1. When you pressed S, it was -1. So this return value in here, or so this float value in here, it acts exactly the same as this. So for that reason, we can treat this float value in here as the same as our axis value in here. So kind of that's our first step. We now have our execution pin, we have our function name, we have our axis value. And then we're gonna need an add force, and we're gonna need this, we're gonna need to create like, so we have this so far. So we're gonna essentially be doing this, but for all of them. So we have move forward, but I'm gonna do one exactly the same as the blueprints, is exactly the same as all these red pins. Input turn, input lookup, and then input move forwards and back. So I'm gonna do the exact same thing in C++. So we're just gonna speed through this a bit, since it's the exact same thing. So there. Okay, so I have all the bind axis, and so I have so far the first function, which is the move forward, and then I'm going to need the move right, and then the turn function, which I currently don't have, but I'm going to create. So I'm just going to create these functions, and I'm going to do the exact same thing as the move forward. So now I have all my function input declarations, I believe. Lookup function. There we go. And now I have the addresses of those functions, so I'm just going to create implementations of these. Move right, return function. And then lookup function. And then, again, all I'm going to do is I'm just going to do the print string method. So I have kind of the structure of what's going on. Lookup function. And they're all printing the same thing because they're all printing values in this case. It's just to make sure that everything is set up correctly, nothing is like messed up. You could alternatively, instead of using a G-engine add screen debug message, you could use a UE log. So if it doesn't work, we'll use a UE log. So we'll do a development build. One thing that is an issue with the UE log is that we're printing a float value, which is a %f. You can't do that with a UE log. So alternatively, you would have to do like UE log, and then you would have to have it as, it has to be a string. So you can maybe store it into a vector. So maybe you could do something like this, v vector, force vector, for example. And then you can do, in the constructor, you can put value, and then do 0, 0. And then in here, you can say force vector. And then since it's a string, you'll do %s. And then we can do force vector dot to string. And to string. And we can, this will return an f string, or this will return, I believe this will return, it won't tell me the return type, but it returns a string. But this prints a tchar array. So to actually convert this string to a tchar, we would have to overload this. We can use overloaded operator, the star overloaded operator to actually print the tchar. You could do this instead of doing this, for example. Instead of using the G engine, you could do something like this to print it. So let me comment that out because I won't use it. And okay, so compiled successfully, and now we can check it out. So in the project, put this back in the scene. And if I run this code, possess the player. If I do W, so the mouse is working. So I'm moving my mouse left and right, and that's working. Doing it up and down, that's working. For some reason, it doesn't seem to register the W and S and A and D. But that's because sometimes this engine, the G engine, doesn't register things properly, and because of that, we could use, so instead of that, I can do a debug. So we can do a VF vector, and we can do a debug string. So we'll use that instead of our regular G engine print. So I'll have that there just to make sure everything's working. Alternatively, you could like close the editor and then open it again. So this one's working, so I'll leave it be. So let's see. The mouse is working. The mouse is working fine. It's just the regular keys that aren't working. So I'll just have, for the regular keys to move right, I'll have this one. And then for the up and down, I'll have this print instead of this print. There's nothing wrong with the code, it's just sometimes the G engine add screen debug function is takes a while to work. Okay, so what is it complaining about? Let's see. Missing semicolon. Oh, of course. Classic. Starting the new year strong. Okay, so let's save it, let's build it. Okay, so it built in the editor. And now we're going to test it. So get rid of that. And then we'll hit play. we're gonna take the output log and hit play. And we notice it's a little bit hard to see. I wonder if I can make it a little bit bigger. Oh. So if I hit W, the value in fact goes to 1. If I hit S, the value does go to -1. Hit A and D. A and D don't seem to be registering. Oh, that's okay. So I'm gonna take this log and then actually just put it in there. So I'm just doing this for like debugging purposes in case you have issues with debugging and you're just starting out. I just want to show you like the different options you can do for debugging your game. So yeah, if you're gonna use a ulog, you have to use a string, and so you can't just plug in the value directly. You have to put it into some placeholder component, and then you can log that component instead. And I have it set up so that it's always gonna print the y value, but this won't be the case because when we, like as we saw in the blueprint version, we can orient our ball like in a different direction in the y-axis, and the y should be, or moving forward should, the move forward function should affect the y values and not the x values. So if we go into our code again, we play it. Wait, sorry. I'm just gonna make sure everything gets refreshed, put it back in, and bring the output log, play the game. So if I do W, you see it's going 1, S it's going -1, D it's going 1, A it's going -1. So we know that our key bindings is working fine. And then our mouse binding is also working fine because I logged it into the screen. So it's going up and down. Okay, so we know the setup is fine now. We have the right setup, meaning we have all these red nodes working, and then we have all these green output nodes working. So now we can focus on the actual logic of things. The first thing we're gonna do is we're gonna have a camera and get right vector. So in our C++ class, we already created a camera. In fact, this camera is that camera I was talking about. So the first thing we'll do is we're actually going to use a force vector. So I'm going to comment this out because we don't need it. But we will need a force vector because the force vector will be oriented in the direction of where the actor or where the camera is oriented. So it might be 1, 0, 0. If we're facing in the positive x-axis, but it could be 0, 1, 0 in the case that we're facing the y-axis. So we need to account for that, and we can do that by using a function in the camera component, which is getRightVector. So camera has a function inside of it called getRightVector. So that's what we're going to do in the code. So we're going to go to the code, and we're going to say camera. So I'm going to say f vector. I'm just going to declare this again, force vector. And then I'm going to set it equal to the camera component. So it will either be 1, 0, 0 or 0, 1, 0. You could also log this to check. So we have a force vector, and oh wait, sorry. That's not going to work because a camera component is of type uCamera component and the force vectors is of type f vector. So we're going to need a function in the camera component called get forward forward vector. What was it called? Well, in the case that it's moving forward, it's actually called get forward vector. So get forward vector. Okay, that's good. So now what we're going to do is we're going to take that forward vector. And what did we do in the blueprints class? We took the forward vector, we put it into this function. And this function, what it did is it multiplied it by our axis value. In this case, our axis value is just the value, which is the parameter here. So what I'm going to do is I'm going to say force vector and dot x. So a force, since it's not a pointer, it's just a regular data type, we can use the dot operator. And then we're going to say equals force vector dot x multiplied by value, because that's what we're doing here. If we notice in our blueprints, that's what we're doing in this node. We take our axis value and multiply it by the camera direction. The camera direction in this case is our force vector, and we get this from get forward vector, and then we multiply it. But we also need to account for in the case where our force vector is actually oriented in the y direction. So we're going to do force vector dot y is equal to force vector dot y multiplied by value. Yeah, to account for if it's oriented in the x direction or if it's oriented in the y direction. If it's oriented in the y direction, the x direction is just going to be 0, so it's going to be some value, which will be 1, times 0, so it's just going to be 0. Now for the other one, it's times this. So I multiplied this by a ball speed, and this ball speed was just set to 500. So what I could do is I can multiply it by force vector times x times value, and then I can multiply that by 500. Or I can make it a variable and multiply it however you want to set it up. That would be a nice challenge activity. Try to make this number into a variable and try to see if you can modify it in the editor. It would be, a hint would be you would use the axis specifiers we used here. So you do like edit anywhere, and then you could do category, you could do add a category or whatever, but you would need this if you're going to do that. So try playing around with this to see if you can get it to show up in the editor, to have this 500 like stored as a variable and show up in the editor. So we have that, and the last thing we have to do is, so we multiplied, so we got this multiplication, and we got this multiplication. So we handled these two. And the last thing we did is we have the static mesh and a function. Okay. Yeah, so we have the static mesh, and then that static mesh gets plugged into this, and then there's a target primitive component. The target primitive, when something is like target is primitive, all that means is, so what this blueprint is telling me is that, hey, like this function you're looking for or you're wanting to put in C++, you'll find it in the primitive component. So let's just do a quick chase. So I'm going to go to uStaticMesh. And the reason I'm going to uStaticMesh is because uStaticMesh inherits from a uMesh. uMesh inherits from a uPrimitive. And if the blueprint is telling the truth, the uPrimitive, I can find something called addForce. And there we go. This is the function we're going to use. So we have a bone name, and then we have an acceleration false. And this is this exact same function, and we even notice it's blueprint callable, so we can call this in the blueprints. That's what the blueprint callable specifier is. So in our C++, we can say, first we're gonna, so we can say mesh component, or what did I name it? I think I called it static mesh. Yeah, I did, yeah, static mesh. So I'm gonna say static mesh, arrow operator, and then add force. And the first argument is the vector, so it's going to be our force vector that we just created. The second argument is the bone name, so I'm just going to do fname bone name. And since I don't want to assign it to any bone, I'm just going to say it's none. And again, if we go to the primitive component.h, that's what it says, fname, and then the default is name underscore none. So I'm just going to do bone name. And then the third argument is going to be, whether our acceleration is true or false, we notice if the acceleration is true, then the mass of the static mesh doesn't matter. So in this case, the mass of our static mesh in the physics section doesn't matter. So we want to make this checkmark true, just like we did in the blueprints class. So this is our blueprints. So we want to do the same thing in our C++. So we're going to say static mesh. So we have the force, and then we're going to say this is true. And then we're going to save that. Yeah, let's just test it out. I think, yeah. So, and one thing we can do is we add the force vector, but then we can also just do a quick print to see what's going on. U log, and we'll do warning, and then we're going to say force vector is, and then we'll do %s, and do force vector dot to string, and then we're going to call a star on it. Okay, so now let's save that and let's build it. We're going to see if this move forward actually works. And all we're going to have to do for the move right is if we look at our blueprints, so if that function actually worked, all we're going to have to do for the blueprints is the only thing that actually changed was the camera. Instead of it calling get forward vector, it actually just called get right vector. So we're just going to do the same thing in our code, but call get right vector instead of get forward vector. So right now it built. So I'm going to test it. I'm going to do an editor build. Okay, so it built. So let's check. Let's check if it works and delete it. I'm going to put in the stage. So I'm going to hit play. Going to maximize the screen. And then we notice it's moving front and back. So what if I orient, oh, I didn't do the orientation thing. So let's do that then. So we got the moving forward and back, but I want to test if it actually is getting the camera direction. I want to test if it's actually getting this camera get forward direction. So to be able to do that, I'm going to have to first implement the turn function. The turn function is, oddly enough, exactly the same as a blueprint. So in our blueprints, we had this add controller yaw input, and all we're going to say is add controller yaw input. Like it's exactly the same. So in our turn, add controller yaw, because yaw is the x and the x-axis, and then we're going to pass value in. And then for the second one, we're going to say add controller pitch input. And then we're going to put value. So we're going to save that and compile it. And we're going to notice that this is all we had to do for the mouse. To get it to orient, all we need to do is call these two functions. And these were the exact same things we did as the add controller yaw input. Just to emphasize, I put this print string, but it's just for debugging. You don't need it when you're actually shipping your game. So I'm gonna build it. Okay. So now let's delete our ball. Let's put our ball here, and let's play. So if I move forward and back, it works. And then what if I orient the camera this way? Oh, and it also works. And we know that this actually is working because, I mean, when we notice I haven't implemented the move right yet. So it wouldn't be able to move right it wouldn't be able to move right unless the camera, unless this function or this logic actually worked. Because I haven't implemented the D and the A key, or I haven't implemented, the moving right. So all I'm gonna do, one thing just to be safe is we want to stop the execution of the player input component like doesn't work. So just stop the program from running if the inputs don't work. So this is just a macro just to be safe. You can leave it in there just so you know something's wrong with the input if something does go wrong. So now I just copied it word for word. Oh wait, I didn't copy anything. Okay, so I'm gonna copy this word for word. Okay, so now I'm just gonna copy this. I'm gonna copy this word for word. I'm gonna paste it in here. Now the only thing I need to change is instead of get forward vector, it would be get right vector. And we'll save that. And the turn works, the lookup works. So hopefully this would be our last build. Okay, it failed. Player input undeclared identifier. Player. Oh, oops, my bad. Okay. Oh, you can't have it in the move forward functions themselves. Just have it in here. Yeah, you just need it in here. So let's build it. Okay, so it built. And now we can look forward and right, go to the right, go to the left. And then if we orient the camera this way, go to the right, go to the left, move forward, turn the camera, move back. Ooh. One thing to do, or one extra thing you could also do is it's a little bit it's not sharp when you turn. Like you can't stop yourself from falling, or sometimes you can. If you want to make it a little bit smoother, I would recommend having this angular dampening to 1. Set this to 1, and then set this to maybe 10, or like 0.5 maybe. Okay, and just to make it a little bit smoother, so it's sharper in the turns, so you have more control over the ball. But yeah, and so that's it. This video took a while to make, so if you enjoyed it, please hit the like button.